everyone, this is Miss Rossi here, and today we're going to be talking about our Unit 10, Day 2 notes about basic volume. So many of these things are things that you've seen before, but just to try to sum it up, and again, how do we answer higher level questions regarding our three-dimensional shapes? All right, so the first thing we're going to talk about is the volume of a prism. So volume, remember, is kind of the amount of space that is inside. Inside the 3D figure. Right, and remember that it is a cubic measure. Right, so things like feet cubed, okay, inches cubed, right? So, because again, we're talking about little cubes, right? A cubic measure. How many of these little cubes can you fit in to the object? All right, so let's see. First one, volume of a prism. Now, one thing about high school geometry that's different than middle school is this notation right here of the big B. All right, so again, this is big B. And big B, what that does is it means it's the area of the base. All right, so if I have a rectangular prism, my volume would be, the area of my base would be length times width. So length times width times height. If I had a different kind of prism, I would change my formula. So let's see when I talk about my cylinder. So when I talk about my cylinder, now my base is a circle. So right here, this is the area of the circle formula. So yes, it is the same exact formula as here, but since my base is different, well, I have a new formula for that. And so what that allows us to do is it allows us to generalize every kind of figure where we can find the area of the base. Now a sphere is a much different kind of game, right? Because a sphere doesn't have any of those flat sides, right? So we've got a circle, three-dimensional circle here. So what this is based on is it's based on the radius. All right, so this formula here, sorry about that. This formula here, right, has to do with our area of a circle a little bit. And then talking about how do you find the area of every circle that's enclosed in there. So this is actually going to be 4/3 times pi r to the third power. Okay, so again, always giving us a cubic measure. All right, now pyramids. Remember we talked about pyramids in the last video. If I take a look at my pyramids can look very different depending on what the base is. So I can have a triangular pyramid, a rectangular pyramid. Notice the rectangle on the bottom, right? Pentagonal, hexagonal, again. And what it does is it changes the number of faces every time. And so when I am finding the volume, again, the big B, right, the base is going to change. So like in this case, this is a rectangle. So the area of a rectangle, length times width. So if I were to kind of plug that in there, I would have volume equals 1/3 the length times width times the height. Now, if I only had a triangle in the bottom, all right, I would need to do volume. So I would need the area of a triangle. So 1/2 base times height. Now, one thing we have to be a little bit careful of is now we've used this letter H twice. So we just have to be careful with our notation. And so we'd have 1/3 times 1/2 base of the triangle times height of the triangle times the height of the prism. So I put a little p there just for height of the prism. And it just helps us distinguish between the two H values. All right, now we have a cone right here. Okay, so a cone, the base is a circle. So volume equals 1/3, right? And the volume, the area of a circle, pi r squared. So pi r squared times the height of the prism, height of the prism. All right, so again, the big B is representing the area of our base. All right, so if I want to find the volume of any shape, I first have to just try to determine what is that shape. So here I'm noticing that I have a triangle and I'm flanked on each side by a rectangle, so a triangular prism. So my triangular prism, so volume equals the big B times the H. But again, big B is the area of that base. So I really have 1/2 base times height times the height of the prism. So the height of the prism ends up being my 8 inches. So plugging my numbers in. So 1/2 times 4 times 4 times 8. Multiply that together. I'm getting 64 inches cubed, or cubic inches. Okay. All right, number 2. Find the volume of the right circular cylinder. So when they say it's a right circular cylinder, all they're telling you is that this base here and height are perpendicular to each other. It's standing straight up. So this one, I'm going to round my answer to the nearest 1/10 of a cubic foot. All right, so again, volume, big B times H. But I know that my base is a circle. So I'm going to plug in for my big B, pi r squared times the height. All right, so pi, my radius there is 9 squared times 6. All right, so I'm going to go to my calculator. Well, actually, yeah, let's multiply that together. All right, so let's see, 9 squared times 6 gives me 486. So 486 pi. It's always nice to write that number. All right, so now I want it to the nearest 1/10. So volume is approximately. So I'm going to multiply that by pi. And I get about 1,526.8. So 1,526.8 cubic feet. Right? And so if I was thinking about saying something like this is a pool, right? I want to know how much water is going to be going in there. All right, number 3. We have a regular pyramid with a square base. Okay, so good to know it's a square. And the side of that base is 12 meters. Okay, the height, 42 meters. What is the volume of the pyramid in cubic meters? All right, so since this is a pyramid, I'm going to be using 1/3 big B times H. Now, 1/3, so I have a length and a width, so that's also 12 meters. So length times width times height. So 1/3 times 12 times 12 times 42. So 1/3 times 12, we had 2 of those, and then times 42, so 2016. So 2016 in my unit meters cubed. All right, number 4. Now we have a cone. So we have a cone, it has a diameter of 8 inches and a height of the whole cone is 12 inches. All right, so I find the volume. So volume, 1/3. Now, since this is a circle, I know it's pi r squared times the height of the prism. So 1/3 pi. Now, if my diameter is 8, my radius then is 4 squared times 12. All right, now let's put the numbers into the calculator first. So 1/3 times 4 squared times 12. And again, a good habit to get into, to be writing down what it is in terms of pi. So 64 pi. Now I want this to the nearest cubic inch. So now multiply that by pi. So the nearest cubic inch, 201 cubic inches. So approximately 201 cubic inches. All right, thank you, and stay tuned for the next